Absolute value inequalities were just these compound inequalities that we learned about in Algebra 2. These were the ones that were the and or statements. These two were or statements when you have the absolute value of something is greater than or equal to a number. The top two, they're your and statements. The reason they're and statements is because the inequality, negative c less than x less than c, is the same thing as negative c is less than x and x is less than c. And remember, this can be written as x is greater than negative c. So basically, when the inequality has a less than or equal to symbol, it's an and statement. The and statements are the ones that when you graph them, they look like this. Two circles with a line connecting them. For greater than or equal to, all I do is change these to closed circles. The or statements, they're the ones that usually had two graphs on the same number line pointing away from each other. These two are actually pointing at each other. We just don't usually write the little arrows. So absolute value of x is greater than c would really look like this. And the only difference between greater than c and greater than or equal to c is that if it were greater than or equal to, these would be closed circles. So the way that I had taught in Algebra 2 for students to solve problems like the absolute value of x minus 5 is less than 2, I told them to write two inequalities. One of the inequalities looks like the original one without the bars. The other inequality, you flip the symbol and you make that negative. Notice that nothing happened to this. The expression that's between the bars is exactly the way it is in the original problem. One of the most common mistakes students make is they think the second inequality makes this the opposite, and that is not what happens. So now one of the answers has to be x is less than 7. The other answer has to be x is greater than 3. Well, here's a great question. Was this supposed to be and or? Well, if you have these memorized, you'll know which one it is. But let's say you don't have them memorized, so you're not sure which one it is. You'll figure it out pretty quickly by graphing it. One of the graphs is x is less than 7, and the other one is going to be x is greater than 3. What's going to happen for absolute value inequalities is that if you graph the two inequalities and they have an overlapping component, that means that this must be the graph and it's an and statement. And the way we usually write this is 3 is less than x is less than 7. That's our compound inequality. So let's do this again with a little bit more complicated problem. But it really is not more complicated because it really just requires us to do basic algebra. The hardest part of solving the absolute value inequalities is making sure you have your two inequalities set up correctly. The first inequality looks like the original one without the bars. The second inequality, you flip the symbol and make this negative. And again, notice that nothing happened to the part that was between the bars. That expression is the same in both problems. Well, now you know how to solve these. 3x is greater than or equal to 2, x is greater than or equal to 2/3 is one of the solutions. And the other one is going to be 3x is less than or equal to negative 6, so x is less than or equal to negative 2. And again, let's say that you don't remember if this is supposed to be an and or an or statement. The way you can figure it out is when you go to graph it. Let's see, there's negative 2, and 2/3 is going to be between 0 and 1. So x greater than or equal to 2/3 is going to have a closed circle at 2/3 pointing to the right. X is less than or equal to negative 2 is going to have a closed circle on negative 2, and the arrow points to the left. Well, that must be an OR statement. Now, another way of writing this answer, this is an acceptable way of writing the answer. In interval notation, we would write this as negative infinity to negative 2 bracket, union, bracket 2/3, comma, infinity. Union is for your OR statements. If I were to go back to the previous problem, and I wanted to write that in interval notation, I would have written it as 3, 7, or you could have also written it as, this would have been, well, no, because you can't write it that way. No, I guess we could have. I guess we could have written it as negative infinity 7 intersection 3, comma, infinity. But we don't usually write it like that when it's an AND statement. In interval notation, we would normally write it like this. Remember that that's the parentheses for an open circle, brackets for a closed circle. Hopefully in Algebra 2, you spent a considerable amount of time working on modeling inequality problems, whether they be absolute value or not. So let's talk about carnival tickets. A carnival has 2 plans for tickets. Plan A has a $5 entrance fee, but the rides are 25 cents a piece. Plan B has a $2 entrance fee, but it's 50 cents for each ride. How many rides would you have to take for Plan A to be less expensive than Plan B? So we want Plan A to be less than Plan B. Now we've got to go back and we've got to write algebraic expressions for each of those plans. Let's use X to represent the number of rides. So Plan A is going to be $5 plus 25 cents a ride. That's going to be 5 plus 0.25x. Remember to convert the 25 cents back into actual monetary form. That needs to be less than Plan B, which is going to be $2 plus 50 cents times x. And now that's just an inequality we can solve like any other algebraic expression. So why don't I get my x's on the same side? It doesn't matter how you want to do it. If you learn to do it by moving the smaller number first, that's fine. So if I move the 25x to the other side, I get 5 is less than 2 plus 0.25x. And then I'm going to get my constants together. So I have 3 is less than 0.25x. And then I'm going to divide by 0.25. I don't need to flip the inequality symbol because I'm not dividing by a negative. And 3 divided by 0.25 is 12. So 12 less than x, that's the same thing as x is greater than 12. So you have to ride more than 12 rides in order for Plan A to be less expensive. So if you know you're going to ride more than 12 rides, then you would get Plan A. But if you know you're not, you'd get Plan B because you'd save some money. The last thing we're going to talk about for inequalities is the relationship between Fahrenheit and Celsius degrees. The instructions on a bottle of medicine indicate that the bottle should be stored at a temperature between 5 degrees and 30 degrees Celsius. What range of temperatures does this correspond to on the Fahrenheit scale? First of all, you need to know what the formula for converting between Fahrenheit and Celsius is. And some of you may have it memorized and some of you may not. Well, let's start with this. Most people have Fahrenheit is equal to 9/5 times Celsius plus 32 memorized. That's the most memorized version of the formula. I know that I want my bottle to be stored. Alright, I want my temperature to be between 5 degrees Celsius and 30 degrees Celsius. Well, there are two ways of going about doing this. One way is, both ways involve converting this equation into C equals. So you need to subtract your 32, and then you need to multiply by 9/5. So there's the formula for converting Fahrenheit into Celsius. Well, I want this to be converted into Fahrenheit. What you could do is you could just plug each number into that formula, find its Celsius equivalent, and then write it as an inequality to show the range. That's probably the way that I would do it. I'm going to show you another way of attacking it. The other way of attacking it is to replace what's in the middle of this inequality with the 9/5. Oops. I messed this up because I forgot to flip this. Sorry about that. When I got rid of the 9/5, it should have become 5/9. So now, let's go back. I can write this as 5/9 f minus 32 in the middle. Well, we talked about compound inequalities like this in the last video. In order to get f to be the only thing left in the middle, first I got to get rid of the 5/9. Well, since that's 5/9 times Fahrenheit minus 32, the opposite is to multiply by its reciprocal. So we're going to multiply everything by 9/5. So I'm going to do 9/5 times 5. It goes away in the middle. And then I'm going to do 9/5 times 30. So I've got 9 is less than f minus 32. I probably don't need that parentheses there. Is less than 54. And then, in order to get rid of the minus 32, I'm going to add the 32 everywhere. So I'm going to get 41 is less than f is less than 86. So it turns out that in Fahrenheit temperatures, I need my pill bottle to be between 41 and 86 degrees Fahrenheit.